We're on chapter 11 now.
Chapter 11. This is probably one of my favorite chapters. And before I go to it, I know I've shared with you why this is one of my favorite chapters. Because this chapter, it should be called amines and amides.
Right, it should be, actually.
It should be.
Yeah.
And when I was true story, when I was working on this chapter one day, I was like, this is boring. I wouldn't want to read this. I want to pull my own nails out rather than go through this book. And I think for me it was a turning point. I was like, what are we really doing here?
Yeah.
I'm writing about decomposition products, which to me are really exciting. And amines and amides is not.
That sounds, boring. And that actually forced us to change the names of all the chapters in this unit.
It changed the entire perspective of the book. And I wrote to Robert and I was like, let's change this to decomposition products. And we knew we were on to something. I can tell you right where I was when I came up. So I was in a restaurant in Sacramento and I was like, oh my gosh. It was exciting. So decomposition products. Let's see, chapter 11. Chapter 11, decomposition products. Okay, so the central molecule, we move away from carbon at this point, and we move into nitrogen.
Yep.
Now, and when we were talking,
for the most part,
when we were talking about aldehydes, you said there was a relationship between amines and aldehydes, the carbonyl group of an aldehyde. And so we're going to go over that. And I think not to complicate things too much, I think it's probably important to draw a formaldehyde molecule and the polarity of it again.
I get to do that again?
Yeah, you get to do
that. Okay, here's formaldehyde. Plus charge, and I'm going to put the hydrogens.
So if we see the polarity, get the hydrogens. Okay, and then you also drew a protein, or an amine in a protein.
An amine that represents a protein.
So go ahead and draw that again.
So here's an amine. I put the electrons for emphasis.
And the electrons denote, because not many people will say, that to them it's an electron. It doesn't necessarily carry a charge.
So that means, but it still means that it's negatively.
It's a negative charge. And there's an interaction between the positive and the negative on these two molecules.
Right.
And that will form that bridge. So it's really important to think about that.
So, yeah.
So where do we find, this is really important, these are in your bottle of embalming fluid. These are in the body.
Right, that's decomposition. These are proteins and polypeptides that have degraded. That's what that represents there.
Okay, so not only have we moved from carbon, we've moved outside of the embalming chemical bottle, and now we're looking at the things that those chemicals will react with in the body.
Right.
And that's a really important designation. I don't think I've ever really made before, right? Okay.
Not yet,
Yeah. And so when we're talking about decomposition products and proteins, and that's kind of the biochemistry stuff,
right.
We'll get into that in more detail. These are, I think we said this in chapter 6 when we were talking about acids and bases. Yeah. This is more alkaline or more basic, right?
Right. That's right.
Yeah, it's more alkaline or basic because it will accept protons.
Right. We talked about hydrogen bonding earlier. This is a kind of compound that will also react with hydrogen, so it's a base.
Okay, so where else do we find these in the body? We find them, let's get examples, right? So proteins, what's an example of a protein? One is keratin, another one is hemoglobin. Hemoglobin has a particular structure, it's a ring structure. We also find these, believe it or not, in nucleic acids, right?
Right, in a DNA and RNA.
DNA and RNA. And I like to point that out because when you are embalming, you cross-link, many people will say proteins. The other thing you're cross-linking is nucleic acids like DNA and RNA. That's also true for bacteria. Like this, let's take a step back. What's kind of cool about formaldehyde or the aldehyde functional group is not just that it preserves tissue, but it also
disinfects.
It disinfects at the same exact time. So that one reaction actually takes care of the disinfection and the preservation step in embalming, which is kind of key. And it's kind of nice because you have to remember only one thing. Which is really kind of cool. Okay, so now if this nitrogen interacts with aldehyde and it's not in a protein, it will neutralize the formaldehyde. Completely change the formaldehyde. It's no longer an aldehyde, and you create urotropin, right? Yeah.
When you have just ammonia, you'll get urotropin.
When you have just ammonia, you'll get. So if you have a body, this is key. If you have a body, I think I said this is a key a lot. So this is one of the.
But it's still a key.
But it is.
Yeah.
It is. If you have a body that's highly decomposed, right? There's a lot of free nitrogen, a lot of ammonia. It neutralizes your formaldehyde.
And then you get
Yeah, and so many people will say the preservative demand of a decomp or a decomposed body is higher than one that is not decomposed. And the rationale for that is there's a lot of free ammonia. It's going to neutralize your aldehyde.
Yeah, so as the proteins break down, they break down into smaller and smaller units. And the more of those smaller units you have, the more formaldehyde you need to To connect them together.
Yeah, to link them together.
To link
stabilize
them
them.
To stabilize. What formaldehyde basically does, as I said earlier, is it's a way of slowing the decomposition. So when these amine groups form, it grabs onto them and prevents them from breaking down further. It holds on to them.
Yeah. And you know what it looks like, which is kind of cool, is it kind of looks like the cover of the book, right?
Right. This
represents a protein, and there's the formaldehyde in the center, and this is the cross.
That's exactly right.
That's
They're formaldehydes holding the protein together.
Okay, and just some fun stuff about decomposition. I do enjoy talking about decomposition. When proteins break down, you'll get different smells, the smells of decomposition. So when ring structures are breaking down, those are pyrroles. You either get scatol,
which is scat, right? That's not a good smell.
Yeah. Indoles, which also have a similar smell to scat.
Yeah.
But when long chain proteins break down, you get
cadaverine,
and you get that's under a group called ptomaines.
Yeah.
Yeah. So you get cadaverine and putrescine.
Yeah, and they're named after their smell, I think.
Yeah, they are. They are indeed. But yeah,
descriptive names.
Yeah, as a protein breaks down, you start to get some of those longer molecules that will smell unpleasant. Yeah. Mm-hmm. I think we covered everything. I think so. Yeah.
That's a Reader's Digest version of that chapter for sure. Yeah.
Sure. If we didn't cover something that you have questions about, let us know in the comments section. We'll get back to you. Robert promises he'll get back to you.
We will write to us and we will respond to you if you have a question.
Yeah. So follow, and any comments, drop them in the comments section so we can get back to you and continue the conversation. We love this.
Yeah.
Love it.